Hello class, today we will be investigating the Continental Drift theory. For the Continental Drift theory, we have a few standards that we're going to go by. Standard 1 is going to be 6-8 LST 7.3. We're going to draw evidence from informational text to support analysis, reflection, and research. 7.ESS.1 is we're going to identify and investigate the properties of minerals. We're going to identify and classify a variety of rocks based on physical characteristics from their origin and explain how they are related using the rock cycle. 7.ESS.2, we're going to construct a model or scale drawing based on an evidence from rock strata and fossil records for how the geologic timescale is used to organize Earth's 4.6 billion year old history. 7.ESS.3, we're going to use simulations or demonstrations to explain how the continental drift theory and how the lithospheric tectonic plates have been and still are in constant motion, resulting in the creation of landforms on the Earth's surface over time. 7.ESS.4, construct an explanation based on evidence found in and around Indiana for how large-scale physical processes such as the karst topography and glaciation have changed the land. 7.ESS.5, we're going to construct a model diagram scales drawing of interior layers of the Earth. We will identify and compare the compositional layers, also known as the chemical layers, and the mechanical, also known as the physical layers of the Earth's interior, including magnetic properties. Our I can statement. I can describe the historical developments that support the plate tectonic theory, how rocks are formed, and how the surrounding environments shape the Earth as we know it. So I can know how the Earth's crust moves and forms new landforms. I will know I have it when I can explain continental drift theory, tectonic plate theory, and how rocks and fossils are formed in my own words. For Wednesday and Thursday, for 9:16 and 9:17, we're going to read and answer the following questions on slides 4 through 9. Those that don't understand what is being said or read, I have it in Spanish right here, so make sure you refer to those as well. Our essential questions. Who is Alfred Wegener? What is the historical evidence that supports the theory of the continental drift? What causes the movement of the continents? As we go through, I'm going to pause and ask you to refer back to your essential question and to answer it. Now, as an introduction to Alfred Wegener, we have a song that we will play.
In the year of 1910, there was a scientist whose name was Alfred Wegener. He noticed that the continents looked just like pieces of a broken puzzle. By 1915, he called it Continental Drift. It caused a rift with his fellow scientists who sang, Alfred Wegener, you are a crazy man.
Okay, so that is an introduction to kind of what Alfred Wegener is all about. Continental Drift was proposed by Alfred Wegener. He was born in 1880 and died in 1930. He proposed the Continental Drift theory. The idea is that the Earth's continents moved apart from a single large continent called Pangaea. Despite a large body of compelling fossil and rock evidence, his theory was rejected by most scientists. He could not explain how the continents moved. So because he couldn't explain or prove how they moved, he was discredited. It was only until the 1960s that the continental drift theory became widely accepted and part of the theory of plate tectonics. Here we have some questions that are going to need to be answered. They will be based off of this video, so make sure you pay attention and rewind the show if you have to.
Don't you just love it when you're right? Of course I do. And so do scientists. The scientific method makes us have to pretend like we aren't. The fact is, the whole scientific history is filled with people who were totally right, and everybody thought they were wrong. Today, I'm going to tell you about one of those people. He changed the way that we look at the Earth. Alfred Wegener was born in 1880 in Germany. He's one of those rare people that's just good at and interested in a lot of different things. He got his degree in astronomy, which is a relatively young field of meteorology, where he pioneered the use of air currents and went on expeditions to Greenland to study polar weather. He's totally badass. He spent winters in building ice swords, and he also made the longest crossing of Greenland's ice cap on foot for the wind. He was also interested in other stuff, including geophysics, which is why he got totally obsessed with this. He couldn't help but notice, like some school children will, that Africa and South America almost look like puzzles. Sure, they're thousands of miles apart, but they really look like they fit together. Of course, other people picked up on this, like I said, he probably did around 4th grade. But another one of Wegener's great qualities is that he wasn't afraid to ask the stupid sounding questions. So we just started asking, continents moving, is that a thing? And if it was a thing, how would we know that it was a thing? And because he was a voracious and curious guy, he was looking for the answers to those questions in all kinds of places and guesswork. He found out that fossils of the same plant species had been found on both sides of the Atlantic. He discovered that the geology of the Appalachians was almost identical to that of the Scottish Highlands. And he learned that the distinctive rock strata found in South Africa were the same as the parts of the South Africa. The continent's Ireland. Finally, in 1914, while laid up in a military hospital bed during World War I, he pieced together his theory that all of the land masses on Earth used to be part of a single continent called the Ur-continent, or the origin of all continents. And over time, the masses moved, scattering fossils and rock patterns around the world. The next year, he published his research in a book, The Origin of Continents and Oceans. And the scientific community responded. They totally freaked out. Geologists dismissed him as a glorified weatherman. They held entire conferences devoted to debunking his book. Even his father-in-law, who was the most prestigious meteorologist in Germany, told him he should have probably stuck with the blue thing. The conventional wisdom at the time was that continents used to be connected by land bridges that later collapsed or were covered by the ocean. That's how they explained stuff like magic plant fossils. Of course, Wegener didn't do himself any favors by being actually pretty wrong about a lot of stuff. But he could not explain. He had no idea how the continents actually drifted. He thought they were just plowing through the Earth's crust like an icebreaker. He also suggested that the centrifugal force of the Earth's rotation was causing the continents to drift, which is just totally kind of crazy. Yeah, so damage had been done, and everybody in Germany thought he was a crazy person. No one would hire him to teach anywhere. The only job he would get was as a meteorology professor in Austria. And that is where he was in 1930, where he decided he wanted to go back to Greenland to set up some weather stations. And during a weeks-long excursion to bring supplies to one of these remote stations, Alfred Wegener disappeared in the blizzard. His body was found the following spring, and it is still there today. Very curious. Right? Because he was crazy. And he stuff. And at the time of his death, people were just starting to understand what the floor of the ocean actually looked like. And decades later, that research showed that there were giant rifts and mountain ranges under the oceans. And those were the boundaries where continental plates were pulling away from each other or crashing against each other. It wasn't until the 1960s that plate tectonics became something widely accepted by the scientific community. Though he wasn't vindicated during his lifetime, he is now respected as one of the greatest scientists of his era. And you can pay your respects to one of the many famous scientists that are now named after him, including the Alfred Wegener Institute for Polar and Caribbean Research, or the Wegener Peninsula of Greenland, where he died, or craters on Mars. So, thanks, Dr. Wegener. All of these fascinating things and more we bring to you on the Science Show, where you can subscribe at YouTube.com.
All right, so right here, based on this video, you're going to answer your questions. For those that don't understand the English, you can read your questions in Spanish, answer them in Spanish, then translate it up here into English. Okay? What two continents did Alfred Wegener first look at and wonder if they fit together like puzzle pieces? Was it North America, Europe and South America, Australia and South America, Africa and Australia, Africa and South America, Africa and North America? Where we often refer to the supercontinent as Pangea. But what term did Alfred Wegener use? What was the term that he named the large landmass in? Refer back to the video and it will tell you. What decade was the Continental Drift theory accepted by scientific community because of the discovery of plate tectonics? Was it 1930s, 1940s, 1950s, 1960s, 1970s, 1980s, or 1990s? Once again, if you don't understand what is being written here, refer back down here. Can you identify Alfred Wegener's and his contributions to the theory of continental drift? So what was some of the things that he asked and formulated that was actually true? So you can refer back to that previous video to get your answer. Explore the historical evidence that supports the continental drift. Where did they match up at? What was shown in two different continents? Describe the process that moves the continents. What is this process called? We have the continental theory. What is the name of the other theory that we discussed? That's where we will be ending for today from Wednesday and Thursday, 9/16, 9/17.